Welcome to you all in my YouTube channel Experience Mathematics. Today in this video I am going to explain how to solve the minimization type of linear programming problem. Before starting, I want you to make sure that you please subscribe my YouTube channel if you have not already subscribed, so that I will be encouraged to make similar videos, and also press bell icon so that you will be informed about my coming videos. So previously, in my previous video, I have explained how to find a maximum value of the objective function subject to the given constraints. And now I am going to explain how to find out the minimum value. Okay, so this minimum value of the objective function problem is same as the maximum value of another objective function related to the same data. Okay, so this given problem is called primal problem, and the next maximization problem based on the same data, that is called the dual problem. Okay, so you have to change this problem into the maximization problem. That changing this minimization problem into maximization problem is called that dual problem. Okay, dual problem of this minimization one. So after changing into maximization type of problem, that can be done by using the simplex method like before. Okay, so now I am going to explain how to obtain the dual problem of this linear programming problem in which we have to find out minimum value. Okay, I'll look at the solution to this question. Let us suppose that A equals to augmented matrix formed from the constraints and the objective function. Okay, so this augmented matrix meaning is it is the matrix formed from the coefficient of the variable and the constants. That is known as the augmented matrix. And here coefficient of x1 is 1, coefficient of x2 is 1, 1, 1, and constant is 8. Constant is written on the side. Its coefficient is 5, coefficient of x2 is 3, constant is 30. Okay, and our here objective functions. In these objective functions we have 10 here, here is 15, and here in constant side we write 0 because there is no any constants. Here this last row is written using this objective function. And now this A matrix equals to this much, and this implies that A transpose is obtained by interchanging row and column. Now first row becomes first column, 1 1 8. Second row becomes second column, 5 3 30. Third row becomes third column, 10 15 0. Now we'll make the line like before. Okay, this is A transpose. Now the corresponding corresponding dual problem of the given linear programming problem is, okay, after transposing we can get the corresponding dual problem of the given linear programming problem. So now we can change from minimization to the maximization. Okay, this minimization problem contains this bigger than sign in these two constants, and in maximization problem there will be lesser than or equal to sign. Is maximum, here we have minimum p, we denote this by maximum c equals to variable. Also we change another variable we use, that is this last row gives us the objective function, that is 8y1 plus 30y2 subject to y1 plus 5y2. Here bigger or equals to, now we change into lesser or equals to 10, because in maximization problem there will be lesser or equal to sign. Subject to this, and y1 plus 3y2 is lesser or equals to 15, and this y1 y2 is bigger or equals to 0. This variables bigger or equals to 0 is same in both minimization and maximization type of problem. Now introducing the slack variables, x1 x2 bigger or equals to 0, we have. So now we will make initial tableau from this. Initial tableau, and like before, how we solve maximization problem, in the same way we proceed. Okay, and basic variables, here we write basic variables and here we have y1 y2 x1 x2 constant, and your RHS right hand side is B. Okay, and here after introducing slack variables, we have after adding this x1 x2 here, this inequality changes into equation. Okay, and this one, first one becomes y1 plus 5y2 and plus x1 plus 0 x2 plus 0 c equals to 10, and second one becomes y1 plus 3y2 plus 0 x1 plus x2 plus 0c equals to 15, and uh, now this objective function, this becomes minus 8y1 minus 30y2 and plus 0 x1 plus 0 x2 plus c equals to 0. Okay, and here we write the coefficients. Coefficient of y1 is 1, y2 is 5, it is 1, 0, 0, and on the right hand side 10, and here we have 1, we have 3 here, 0, 1, 0, 15. Here is now in the bottom row we have this minus 8, minus 30, 0, 0, 1 and 0. Okay, and our basic variables, here we have 1 and here 0, here 0, here 1, so these two are the basic variables, x1, x2, and in this bottom row we should see which one is more negative. Okay, this minus 30 is more negative, so this is the column containing more negative number in the bottom row, that is the pivot column. Okay, this is pivot column. The second row is the pivot column because this is more negative in comparison to other elements in the bottom row. And now we will divide the element in RHS by the elements in pivot column. Now your 10 over 5 equals to 2 and 15 divided by 3 equals to 5. Okay, that is 2 is smaller than 5, so here 2 we have obtained by dividing 10 by 5, so 5 is the pivot element. Okay, so 5 is pivot element. Okay, And uh, as I have already explained in previous video also, we have to make this pivot element 1, and remaining element of the column we should make 0. Okay, and so to make this one, we divide throughout by 5. So now R1, in R1 we perform R1 over 5. Okay, performing R1 in R1 divided by 5. Now we again make a next table, table number 2, table 2. Okay, this is initial tableau, that is table first, and in the same way we write basic variables, and now we write this y1, y2, x1, x2, c, RHS, b, and we have to divide this throughout by 5. So here will be 1 over 5, here will be 1, here is 1 over 5, this 0 over 5, 0, 0 here, 10 divided by 5, here will be 2. Okay, now here when this pivot element is made 1, now this becomes the entering variable, and this becomes departing variable. So x1 will be replaced by y2. So y2, this is departed, this is entering variable here, and here is x2, and we write the elements of the column in the same way: 1, 3, 0, 1, 0, 15. And here -8, -30, 0, 0, 1, 0. And now our next step is, okay, here this first row we have divided throughout by 5, element in the second row we copied same, element in the bottom row also we copied same. And our next work is to make this element except the pivot element, other elements in the column 0 we have to make at 0. So for that, what we will do is performing what we will perform is R2, in R2 minus 3 R1. Okay, so from R2 this 3 R1 we subtract, we multiply first row by R3 and subtract from second row, and R3, in R3 what we will perform is R3 plus 30 R1. Okay, this thing we will perform, and after performing this, our basic variable we can write BB in short, y1, y2, x1, x2, c, and RHS is B. Okay, and here basic variable y2, here 1 over 5 same, here 1, 1 over 5, 0, 0, and 2, and here R2 minus 3R1. Let's do some rough work. R2 is 1 minus 3R1, 3 over 5. So this gives you 5 was 5 minus 3, 2 over 5. Okay, so here we write 2 over 5, and 3 minus this 3, it will be 0, and here will be 0 minus 3 over 5, that is minus 3 over 5, and 1 minus 3 times 0, that will be 1. 0 minus 3 times 0, that will also be 0. 15 minus 3 to the 6, that will be 9. And now in the bottom row, here in the bottom row, minus 8 plus 30 times 1 over 5, minus 8 plus 30 times 1 over 5, 5 6 is 30, that will be minus 2. So here will be minus 2, and 0 plus 30, here minus 30 and plus 30 times 1, that will be 0, and 0 plus 30 times 1 over 5, 5 6 30, that will be 6, and 0 plus 30 times 0, that will be 0 itself. 1 plus 30 times 0, that will also be 1, and 0 plus 30 times 2, that will be 60. Okay, and again the elements of bottom row are not non-zero. Okay, elements in the bottom row must be non-zero to get the final solution. So still this is negative. Okay, so which is more negative, that will be, that column will be the pivot column. Okay, and here this first column is the pivot column. This column is pivot column. Okay, this column is the pivot column, and now we divide this RHS by the elements of the pivot column. 2 divided by 1 over 5. Now 2 divided by 1 over 5, that will be 2 times 5, 10, and next to that 9 divided by 2 over 5, 9 divided by 2 over 5, 9 times 5 over 2, that will be 45 over 2 will be 22.5, that is 10 is lesser than 22.5. That means this 1 over 5 is this is pivot element. Okay, this 1 over 5 is the pivot element. So to make this 1, we multiply this first row throughout by 5. Okay, 5 times R1. We multiply first row by 5. Now performing R1, 5 times R1. Now like before, we write basic variable y1, y2, x1, x2, c, and RHS b. Okay, and when we multiply throughout by 5, and that 5 times 1 over 5, that will be 1. Here will be 5, here will be 1, here will be 0, here will be 0, here will be 10, multiplying throughout by 5, and other elements will be same. 2 over 5, 0, minus 3 over 5, 1, 0, and 9. And now after we have made this element 1, now this variable will be entering variable. So previously there was y2, now that y2 will be departing variable, and this y1 will be entering variable. Okay, y1 enters here, and this x2 is same, and this bottom row elements are also same. Okay, and our next work, like before, is we have to make other element except the pivot element 0. Okay, in this pivot column, except pivot element, other elements we should make it 0. So for that we will do this operation, performing R2 in R2 minus 2 over 5 R1, and from R3 also R3 plus 2R1. This operation we will carry out, and now we'll copy the table and carry out the same operation. Basic variable y1, y2, x1, x2, c, and RHS there is b. And now here we have y1 and x2, and here in first row we have elements same, 1, 5, 1, 0, 0, and 10, and here from R2 2 by 5 of R1 we subtract, R2 minus 2 by 5 of R1, that will be 0 here. And let's do rough work here on the right side. So 0 minus 2 by 5 times 5, that will be minus 2 here, minus 2, and minus 3 over 5. This is a rough work. 3 over 5 minus 2 over 5, that will be minus 1. So we have minus 1 here, and 1 minus 2 by 5 times 0, that will be 1 itself. 0 minus 2 by 5 of this, it will also be 0. And 9 minus 2 by 5 of 10, 5 to the 10, 9 minus 4, that will be 5. Okay, so here will be 5. Okay, so here this minus 2 by 5 of this 0, 0 minus 2 by 5 of this minus 3 by 5 minus 2 over 5 of this. We have got minus 1, 1 minus 2 by 5 of this 1, 0 minus 2 by 5 of 0, we have this. Okay, and now in bottom row from R3, this is row 3, R3 plus 2R1. Okay, in R3 we add twice of row 1, minus 2 plus 2 times 1, that will be 0, and 0 plus 2 times 5, that will be 10, 6 times 6 plus 2 times 1, that will be 8, and 0 plus 2 times 0, that will be 0, 1 plus 2 times 0, that will also be 1, 60 plus 2 times 10, 60 plus 20, that will be 80. Okay, and now therefore maximum of C equals to our new objective function is C, as you can see here. In a dual problem, corresponding dual problem, the given LP problem is maximum C here. Okay, so maximum C we can find out from this, from dual problem we have solved. So maximum C equals to, we get from this, that is 88 y1 equals to here 10. Okay, so y1 we have got here 10 because here we have made it 1, and so y1 became entering variable. Okay, this became basic variable, so we have got its value, but this y2 is not the basic variable, so y2 will be 0. Okay, which is not basic variable, that will be 0. So according to the definition of the basic variable, the variable that are non-zero are called basic variable, and the variable that are zero are called non-basic variables. Okay, so here y1 is basic variable, non-zero variable, its value is 10, but this y2 is non-basic variable, so its value becomes 0, and that is minimum P. Okay, so maximization of the one problem will be the minimization of the another problem. Okay, or minimization of one problem will be maximization of the another problem based on the same data. So minimization of P will also be same value 88, but our variable in minimization problem was x1 and x2, so x1 value from here is 8, and x2 value from here is 0. Okay, in this way we have solved minimization problem using simplex method, using the same idea, but we have changed minimization problem into the maximization problem. Okay, and that making minimization problem to that maximization problem, that is called the dual problem. Okay, and the process is same like before, and in this way both maximization problem and minimization problem can be solved by using simplex method. Thank you for watching. I hope that you found this video helpful. Before going, I want you to make sure that you subscribe my channel, so that I will be encouraged to make similar videos, and also press bell icon so that you will be informed about my coming videos. Thank you very much.